Good morning. Today we look at solving percent problems. And sometimes people find these tricky. I don't want them to scare you off. Really, again, it's just a matter of organizing the information you have and using what makes sense to solve the problem. So, the first example in your Google Doc, you can follow along with that if you want, is a boy, I forget his name. He's 13 years old, and right now he's 170, or just made up a number, 155 centimeters tall. And the question tells us that this is 90% of his full height. So how are we going to find out how tall this guy's supposed to be when he's fully grown? So we take his height now, which is 155 centimeters, and we divide by the percentage tall he is now, which is 90. And I'm going to get rid of this times 100 for right now. So 155 divided by 90 gives me a total of 17.72. And if I want to multiply that by 100, and why that makes sense is 100% is his full height. He's not going to grow any taller, so that is him at 100% of his height. So I multiply that by 100, and I get 177.2 centimeters. And again, I can stop and think, does this make sense? Well, if he's 155 centimeters tall now, and that's 90% of his full height, he's pretty close to fully grown. He's only going to grow 10% more. 177.2 makes sense to me. Even if I make a mistake in the math, I've got the concept solved. So let's try another one. Say there's a girl who's 140 centimeters tall, and that is 85% of her full height. We will take 140, divide by 85, and grab my calculator. 140 divided by 85% is 1 decimal. I'm going to say 6.5 because I have 647, so I'm going to round. And 1 decimal 6.5 times 100 means this girl will be 165 centimeters tall. So how tall she is now, what percentage is that of her original height, times by 100 because 100 is her full height. Can use this also for things that, say for example, something's on sale. And I'm just going to erase this example because I don't want to get rid of what's down there right now. So let's say I have a price of a, I don't know, sweatshirt. And let's say that sweatshirt is $14.99. And that's on sale. So $14.99, and this is 75% of its original price. Now it's important to note here, it's not 75% off. The 100% of the price minus 75 tells us this is 25% off. We need to know the percentage left, not the percentage off. And we do the exact same thing. $14.99, clear, $14.99 divided by 75 equals 0.199. We can also change that to 0.2. If I multiply by 100, which means that's what the price would have been at full price, I know that full price, the sweatshirt was $20. So it works with money, works with height, works with the height of a plant that's growing. Okay, so we can use this math. Just remember, when we're using this digit, it's the amount left over from 100 once we take that percentage off. So if the sweatshirt was on sale 30% off, 100 minus 30, this number would become 75. If it was 50% off, this number would be 50. Okay? Next, we're going to look at a price increase. So if I have a price increase, and the example in the Google Doc is milk. So the new price for milk is $1.25. The old price for milk is 95 cents. If I take the new price, I subtract the old price, I get a 30 cents difference. So I'm going to take that increase, which is 30 cents, and I'm going to divide it by the original price, which is 95 cents. You can write this as cents or as decimals. The Google Doc example actually writes it just as the money. So 30 cents over the original price of 95 cents. This just stops us from having to multiply by 100 at the end. So we know that 30 divided by 95 gives me 0.32. If I multiply that by 100, 0.32 times 100, I get 32%. The increase in the price of milk is 32%, from $1.25 to 95 cents. So let's review this one more time. New price, subtract the original price, gives us the price increase. Price increase divided by the original price gives us the decimal, times 100 gives us the percentage of that markup. This is used a lot. For example, we know if we go to Best Buy to buy a big screen TV, we know that Best Buy did not pay what we're paying. They mark up the cost of that TV. So if a TV was bought by Best Buy for $750 and they sell it for $1,200, if we want to know the percentage markup, so what we're paying to Best Buy just for the pleasure of going into their store, we would do the same thing. We would subtract the new price from the original price, so the price we pay, subtract the price Best Buy pays, and that will give us the price increase. We'll take that price increase, divide it by that original cost, and it will tell us the price markup. So let's look at that. Let's see if we can solve that problem I just gave you now. And seeing as I made those numbers up as I went, I might change them a bit because I honestly don't remember what I said. So if the new price of the TV is $1,200, and the original price, so Best Buy bought it from Sony for $750. The first thing we're going to do is 1,200 subtract 750, and that gives us 450. Then we take that price increase, 450, divided by the original price, 750. And again, I'm going to grab my calculator, and I do 450 divided by 750 equals 0.6 times 100 to get that percent, and I get 60%. If Best Buy bought the TV from Sony for $750 and they sold it to me for $1,200, that means they marked up that price of the TV by 60%. So there's lots of uses for this math. It's a matter of stopping and thinking through what makes the most sense. Again, new price subtract old price is the price increase. Price increase divided by original price gives us the markup. Again, there's some more examples in your Google Doc if you need more help, and you can always reach out to me and I'm happy to help you. If you get stuck on any questions, just give them a try. Show me what you think you're supposed to do. I'm not going to say, oh gosh, look, that doesn't make sense. I want you to show me, because some people have just been writing down, I don't get this question. Show me what you think you're supposed to do. All right, everybody, have an awesome day.